Welcome everybody to Algebra 2, Section 6.5, Radicals and Rational Exponent Review. So there is nothing new in this lesson at all. This is purely review of lessons 1 through 4 smashed all together. So without further ado, let's dive into it. So numbers 1, 2, and 3, we're simplifying these radicals. So let's take these part by part. So square root of 300 m to the 4th, n to the 25th. So square root of 300, square root of m to the 4th, and square root of n to the 25th. So square root of 300 would be the square root of 100 and the square root of 3, which is 10 times the square root of 3. Because 100 is a perfect square. Then square root of m to the 4th is m to the power of 4 over 2, because the index or root is secretly 2 on that square root. And so that is m to the power of 2, or 2 over 1, as it reduces. And n to the power, or n square root of n to the power of 25 is really n to the power of 25 over 2. That'll be helpful here, because that's n to the power of 12 and 1/2. Because 2 goes into 25 12 times with 1 remaining. So now we'll write this back in a radical with 10 outside the radical, m squared outside the radical, and n to the 12th outside the radical. For the variables, it was the exponents not part of the fractions. Then inside the radical, it's the square root of 3. Make sure that it doesn't look like we're doing the 12th root. No m's because there's no fractions on exponents, but n to the power of 1 because it's the numerator on the exponent. And that would be our answer. Now we'll move on to number 2. And we'll do the same thing, but this is a cube root. So we'll have cube root of negative 72, cube root of 8 to the 9th, and cube root of b squared. Cube root of negative 72 is the cube root of negative 8 and 9. Cube root of negative 8 is negative 2 times the cube root of 9. Remember, we always want to make the perfect cube the negative number, so that way the negative is outside the radical rather than inside the radical. Cube root of 8 to the 9th is 8 to the power of 9 over 3, which just reduces nicely to 8 to the power of 3. And a to the power, or cube root of b to the power of 2 is b to the power of 2 over 3, which doesn't reduce or become a mixed number, so we're just going to leave it as is. So as we rewrite this, negative 2a cubed is outside the radical, but no b's because there was no whole number on the exponent. And then inside the cube root, we have the 9, no a's because there's no fraction on the exponent for a, and b to the power of 2. Because that's the numerator on the fraction for the b. And that'd be our answer. On to number 3, same idea, but 4th roots. So 4th root of 81, 4th root of m to the power of 11, and 4th root of n to the 20th. So look for biggest perfect fourths that are factors of 81, and we're like, oh wait, 81 is a perfect fourth. It's just 3. 4th root of m to the 11th is m to the power of 11 over 4. 4 goes into 11 2 times with 3 remaining, so giving us 3 over 4. 4th root of n to the power of 20 is 20 over 4, which reduces very well to n to the power of 5 with no fraction. So for our final answer, we have 3 outside the radical, m squared outside the radical, and n to the 5th outside the radical. Then we have the 4th root of quite literally just m squared inside the radical. No numbers, no n's. Moving on, next, operations with radicals. So here it says perform the indicated operations and writing your answer in simplest radical forms. You'll see on like problems 4 and 5, for example, you're doing some adding and subtracting. On problems 6 and 7, you're doing some multiplying. And on 8, 9, 10, 11, you're having to distribute which is more multiplying. And then we'll be having to add and combine common radicals. And then 12 and 13 will be dividing. And then we'll progress to more problems on the next page. So number 4, remember when we add and subtract radicals, we have to have the same index or root and the same radicand or inside. So these are all square roots, so there's a chance we'll be able to simplify all of them or combine all of them, but maybe not, depending on if the radicands end up being the same or not. I said end up being the same because we need to simplify them first. So 4 square root of 98 is really the square root of 49 times the square root of 2. The square root of 49 is 7, so it's 4 times 7 times the square root of 2. So that's 28 times the square root of 2. So I'm going to now simplify the next one. The square root of 150 is the square root of 25 times the square root of 6. So that is really 5 times the square root of 6, which doesn't multiply with anything outside the radical because there's only a 1 outside the radical that was invisible. So I'm just going to rewrite plus 5 square root 6 in the next step. And then the 2 square root 32. Square root 32 is the square root of 16 times the square root of 2. And the square root of 16 is really just 2. Or excuse me, try that again. The square root of 16 is really just 4. And negative 2 times 4 is negative 8. And now, as far as common radicals, we have square root 2, square root 2. So those can combine. So we combine the coefficients. 28 minus 8 gives us 20 square root 2. And we just rewrite the plus 5 square root 6. And we call it good. Number 5, more of the same, but now we have some fourth roots and third roots. So since this is a fourth root, we won't be able to combine it with these others. That's okay. We'll just still look to simplify. Well, this first one doesn't simplify. That's whatever. So we'll look to simplify the next one, though. So 7 times the cube root of 40, that'll be 7 times the cube root of 8. And the cube root of 5. Cube root of 8 is 2 times the cube root of 5. That's 14 times the cube root of 5. The next one, cube root of 320, ends up being the cube root of 64 and the cube root of 5. Cube root of 64 is 4 times the cube root of 5, which has nothing to multiply with, so I'm just rewriting it in the blue. And this whole time, the 10's fourth root of 5 is just staying the same, it's just getting rewritten over and over again. But to stay consistent in the color, I'm changing the color between each step still. And as we look to see common radicals, cube root of 5 can combine with cube root of 5, but this first one can't combine with it because, once again, it's a fourth root, even though the radicand, or the inside, is the same. So we get 10 times the fourth root of 5, and if we combine the others, we get 10 times the cube root of 5, as we do 14 minus 4. And we're done. On to number 6. As we multiply, remember that we multiply the outsides, the regular numbers together, the coefficients, and we multiply the insides, or the radicands, together. And so we do 3 times 7 is 21. On the inside, we still have the fourth root, but 8 times 32 gives us 256. We look to simplify the fourth root of 256. The fourth root of 256 actually just a perfect fourth in and of itself, so this becomes 21 times 4, which is 84. It doesn't like my attempt at drawing an 8 for some reason. There we go. Number 7, no outsides to multiply, so we'll just have the cube root and multiply the inside. So negative 6 times 18 would be negative 108. And as we multiply the x's, I made my radical too small. As we multiply those x's, we add the exponents to get x to the 9th. Now we need to simplify each of these. So cube root of negative 108 cube root of x to the power 9. Cube root of negative 108 is the cube root of negative, ooh, I almost did the wrong number there, 27 times the cube root of 4, which would then be negative 3 times the cube root of 4. Remembering, want to make sure the negative's outside the radical. Oh, sorry. I said cube root of 4, and then I wrote the fourth root of 4. And then the cube root of x to the 9th is x to the power of 9 over 3, which simplifies quite nicely to x to the power of 3. And so now, this is negative 3 x to the 3rd times the cube root of 4. That's our answer. Moving on to number 8. We're distributing, so negative square root of 3 times 2 and the square root of 24. So square root of 3 times 2 is just 2 times square root of 3. And square root of 3 times square root of 24 is negative square root of 72. Square root of 72 can simplify, and so 2 square root 3 minus square root 36 times square root 2. Square root of 36 is 6. So we have 2 square root 3 minus 6 square root 2. Can't combine those because they're different radicals, different insides, so we're done. If you could combine them, you would, though. Moving on to number 9. 2 terms in each parenthesis, they're both binomials multiplying together. And so we're going to have to distribute, or FOIL as we often call it. 4 times negative 2 is negative 8. 4 times square root of 5 is 4 square root 5. 3 square root 5 times negative 2 is negative 6 square root 5. And 3 square root 5 times square root 5, this is something that some of us may benefit, writing off to the side. 3 square root 5 times square root 5. Remember, when you multiply a square root times itself, you just get whatever's inside, the radicand itself. So 3 times 5, which is 15. And so plus 15. And so now as we combine like terms, negative 8 plus 15 is 7. And we can combine these square roots of 5, since they're both common radicals. And we get 4 minus 6 is negative 2. Square root 5. And now we'll move on to number 10. And we'll do the same thing. 1 times 1 is 1. 1 times negative 7 square root 3 is negative 7 square root 3. 7 square root 3 times 1 is 7 square root 3. And 7 square root 3 times negative 7 square root 3, once again, is something some of us may benefit of writing off to the side. 7 square root 3 times negative 7 square root 3 becomes 7 times negative 7 times 3, which is negative 147. Or 49 times 3, by the way. Negative 49 times 3. Anyway, 1 minus 147 would be negative 146. And as we combine these square roots of 3, because they're both common radicals, square root 3, you get 0. So you don't write anything, giving you just negative 146. On to number 11. Remember, since there's an addition or subtraction sign inside the parentheses, you cannot take this exponent inside the parentheses. That's not how that works. So instead, we have to write it out twice. 3 plus the square root of 6 times 3 plus the square root of 6. Literally 2 of them multiplying together. And then now we do the same thing we did on the last 2 problems. 3 times 3 is 9. 3 times square root of 6 is 3 square root 6. Square root 6 times 3 is again 3 square root 6. And square root 6 times square root 6 is 6. 9 plus 6 is 15. And 3 square root 6 plus 3 square root 6 is 6 square root 6. And we're done. because you can't combine those. And you can't simplify the square root of 6. Moving on to number 12. We got some division. You want to divide the outsides, divide the insides, and then look to simplify. So, negative 49 and 9. I think I said negative 49, but I meant negative 45 and 9, if I didn't say that. So negative 45 and 9 simplify to negative 5, and the square root of 156 and square root of 3. 156 divided by 3 is just 52, so square root of 52. Now I look to simplify the square root of 52. That does simplify, so we get negative 5 times the square root of 4 times the square root of 13, which is negative 5 times 2 times the square root of 13, aka negative 10 times the square root of 13. That's our answer. Moving on to number 13. Same thing here, but with variables. And remember, when the bases are the same base, the same variable divide, we subtract the exponents. So inside and inside, we subtract those exponents. 20 minus 3 gives us r to the 17th. I should make sure that this is inside the 4th root. And then 9 minus 1 for s is s to the 8th. And then individually I say, okay, the 4th root of r to the 17th, 4th root of s to the 8th. This is r to the power of 17 over 4, s to the power of 8 over 4, 17 over 4, well, 4 goes into 17 4 times, with 1 out of 4 remaining, 1/4, and 8 over 4 just reduces perfectly to 2. So outside the radical, you have r to the 4th s squared, and inside the radical you have the 4th root of r to the 1st, because that's the numerator is 1. On to our second page. More division. We look to simplify, but you can't simplify 50 and 81. So we make them separate square roots. Some of us might not need to write this step, and that's okay, but we do look to simplify each of these. The square root of 50 is the square root of 25, and the square root of 81 is just 9. Oh, sorry. The square root of 50 is the square root of 25 times the square root of 2, and the square root of 81 is just 9. And then the square root of 25 times the square root of 2 is just 5 times the square root of 2. And so you get 5 times the square root of 2 over 9, and the regular numbers, 5 and 9, don't simplify, so you're done there. Number 15. Same story here. We look to simplify anything we can. So we can't simplify the 3 and the 16, nor can we simplify a and b. So some of us may benefit from writing these as separate radicals, so I will write them as separate radicals. If this lets me, we'll see if it cooperates. It's wanting to not cooperate. So we have the 4th root of 3a over the 4th root of 16b to the 8th. And now, since we have some variables going on as well, I will do separate ones over here. So the 4th root of 3, 4th root of a, 4th root of 16, and the 4th root of b to the 8th. And as we work on these, 4th root of b to the 3rd, I can't simplify that, so that's just going to stay the same. 4th root of a, also can't simplify that because it's 1 over 4, which doesn't simplify or reduce or become a mixed number. 4th root of 16 is just 2. And the 4th root of b to the 8th is b to the power of 8 over 2, which works out very nicely to just be b squared. So the bottom works out quite nicely, and nothing changes on the top. So the top, once again, is still the 4th root of 3a. The bottom becomes 2b squared. Nothing simplifies, and we're done. Moving on to number 16. Square root of 6 over 4 times the square root of 3. Once again, we want to see if we can simplify insides with insides, outsides with outsides. There's no outside on the top to simplify, but there's outsides or insides to simplify top and bottom. 6 and 3 simplify by 3, and so we'll end up getting the square root of 2 over 4 square root of 1. Technically don't need to write the square root of 1 on the bottom in this scenario because it would just be 4 times 1, which last I checked is just 4. Now we can't simplify the square root of 2, so we're done. Moving on to number 17. We again look to see it. Can we simplify 8x and 5? No, we cannot. So some of us may benefit from writing this out. Square root of 8x, square root of 5. And now, can we simplify the square root of 8? Yes. Do we need to right away? That's up to you. But what I want to talk about first and foremost right now is the fact that we cannot end the problem with a radical in the denominator. We need to quote-unquote rationalize it is what we call it. And that's the process by which we multiply the top and the bottom by something. And here we'd multiply the top and the bottom by the square root of 5, very specifically. Now, whether or not you simplify the square root of 8x, specifically the square root of 8 first or not, is up to you. Some people may, some people may not. It doesn't matter. I'll show it either way, just like I did in lesson 6.4 when we went over it. So let's assume I don't here at first. And so I'll multiply the top and bottom by the square root of 5. And I'll get the square root of 40x over this just normal 5. So I no longer have a radical in the bottom, which is my goal. And as I simplify the square root of 40x, I can't simplify the square root of x, y'all. And the reason why is because this exponent of 1 is smaller than the index of 2 out here. Anytime the exponent is smaller than the index, it won't be able to become a mixed number, and thus we can't simplify it. So I really need to simplify the square root of 40. Square root of 40, well, what does that simplify into? Okay, well, that's the square root of 4 and the square root of 10, which is really just 2 times the square root of 10. So that's 2 square root 10x. Make sure we have the x in there, over 5. The regular numbers 2 and 5 don't reduce, so we're done. What if we reduced early? Okay, well, if you reduced early, let's say you're at the green step again, so square root of 8x over square root of 5. You reduce the square root of 8x, so that still reduces square root of 8. So it's square root of 8. That becomes square root of 4, square root of 2, which becomes 2 square root of 2. So that gives you 2 square root of 2x over square root of 5. We're going to multiply the top and the bottom by the square root of 5, which gives you 2 times the square root of 10x over 5. The exact same answer we got up in the purple. I honestly typically do the bottom one myself. That's my preference, just because it keeps numbers smaller, and I like keeping numbers smaller. Now, whenever you can simplify the denominator, I always do that before I would multiply the top and bottom by something. All right, number 18. 2 minus the square root of 12 over the square root of 3. So here, pardon me, square root of 3, okay, if these all had a square root, I'd look to see if I could simplify all 3 radicals in the inside of them by the same number. But this first one doesn't even have a radical, so I can't do that. So I can't just simplify these two unless I were to split the fraction, which is an option. I talked about that in 6.4, but I just won't show it in this example here. If you want to see it, just come see me at some point. You could simplify this square root of 12 early on this problem if you want. It's actually a little bit easier not to on this problem, but I'll show what happens if you do on this one as well in just a moment. But first, let's just say we multiply the top and bottom by the square root of 3 because we can't have a radical on the bottom for our answer. So we distribute the square root of 3 on the top, and we get 2 square root of 3 minus the square root of 36 over regular 3. And 2 square root of 3 doesn't simplify, so it just stays 2 square root of 3. But square root of 36 is 6. over 3. And if we could simplify all 3 regular numbers, we would, but we can't, so we're done. Now, I was saying I was going to talk about what would you do if you'd simplify early with that square root 12, so let's talk about that. So that would be square root of 4 and square root of 3, so 2 minus square root of 4, square root of 3 over square root of 3, which is 2 minus 2 square root of 3 over square root of 3. And so now I still multiply the top and bottom by the square root of 3. And so this is 2 square root of 3 minus 2 times square root of 3 times square root of 3 is 2 times 3, which is 6 over 3. And so you get the exact same answer. Once again, it really doesn't matter which way you do it. Number 19 here. Here you can simplify the square root of 12, and since it's on the denominator, I definitely want to do that. Anytime you can simplify the denominator, you want to do that before you multiply. And so here you have 3 square root of 3 over 4 square root of 4 times square root of 3. So I'm just going to keep rewriting the top until I have to multiply the top and bottom by the same thing. And that's 4 times 2 times square root of 3 on the bottom. So again, just rewriting the top one more time. Over 8 square root of 3. Now when I go to multiply, I'm multiplying by the square root of 3 instead of the square root of 12. That's going to save me having to simplify the square root of 12 multiple times, because I just simplified it once right away. Because otherwise I'd be multiplying this whole thing originally by the square root of 12. And I have to then simplify each of those square root of 12s that I multiply in. And so as I multiply these, I get 3 square root of 3 plus 3, because square root of 3 times itself, over 8 times 3, which is 24. All 3 of these regular numbers can reduce by 3, so we'll reduce all 3 of these regular numbers by 3, giving me 1 square root of 3, aka square root of 3, plus 1 over 8. If you don't have this plus 1, that's wrong, because saying that you're adding 1 versus adding nothing are 2 different things. Moving on to number 20. 5 minus 4 square root of 2 over 4 minus 3 square root of 2. So here we have to multiply by something different, and we can't just simplify right away. We have to multiply by what we call the conjugate. The conjugate is the denominator, but with the sign in the middle changed. So if this was negative or positive, that has no impact. We still multiply by whatever the denominator is, just the middle sign changes. So it's 4 plus 3 square root of 2 on the top and the bottom. And we distribute. So 5 times 4 is 20. 5 times 3 square root of 2 is 15 square root of 2. Negative 4 square root of 2 times 4 is negative 16 square root of 2. And negative 4 square root of 2 times 3 square root of 2. Some of us may benefit from seeing that off to the side. That would end up being negative 12 times 2, because square root of 2 times square root of 2 is 2, which is negative 24. I got the negative 12 from negative 4 times 3, by the way. Over, it's at the bottom now, which works out nicer. 4 times 4 is 16, not the top was bad, to be clear. 4 times 3 square root of 2 is 12 square root of 2. Negative 3 square root of 2 times 4 was negative 12 square root of 2. And negative 3 square root of 2 times 3 square root of 2. Some of us may benefit again from seeing it off the side. So we'll have negative 9 times 2. Negative 9 is negative 3 times 3. Square root of 2 times 2 is 2, and that's negative 18. Now we'll look to combine like terms. So in the numerator, we can combine the 20 and the negative 24 and give us negative 4. We can also combine those square root 2's and give us negative 1 square root 2, or just minus square root 2. In the denominator, we can combine 16 minus 18 and give us negative 2. We can combine those 12 square root 2's, which give us no square root 2's, which was the whole point of multiplying by the conjugate, is that we would no longer have a radical in the denominator. If that doesn't occur, we don't zero these out, then we did something wrong. Now we check this step to see if we can simplify all three regular numbers. This is technically a 1 here. We cannot simplify all three regular numbers, so we're done. Now if you wanted to, you could say that since all three are negative, you could divide or simplify all of them by a negative 1. So you could either call this your answer, or you could call it 4 plus square root 2 over 2. And that would be perfectly acceptable as well. Honestly preferred, but I would accept all three negatives as well. I'll be nice and do that. Number 21 here. So here we're going to multiply again by the complex conjugate. So I mean just the conjugate. Complex conjugate is when you have imaginary involved. So it'd be the square root of 3 minus 5. Remember, it's the denominator, but you just change the sign in between the two terms. So 2 times square root of 3 is 2 square root 3. 2 times negative 5 is negative 10. 3 square root 3 times square root 3 is 3 times 3, which is 9. And 3 square root 3 times negative 5 is negative 15 square root 3. Over square root 3 times square root 3 is 3. Square root 3 times negative 5 is negative 5 square root 3. 5 square root 3, or 5 times square root 3 is just 5 square root 3. So those middle terms we're going to zero out again, which is good. The whole reason we're doing this. 5 times negative 5 is negative 25. So on top, we combine the negative 10 and 9, for example, and get negative 1. And we combine those radical 3's, the root 3's, and we end up getting negative 13 times the square root of 3. On the bottom, we combine the 3 minus 25 and get negative 22. Combine those middle terms and we get nothing there. We get no square root 3, so we don't write it. And you look to simplify all three of these, but nothing goes into all three numbers. But they are all negative, so if you wanted to, you could divide them all or simplify them all by negative 1. 1 plus 13 square root 3 all over 22, which is preferred. Moving on to 22 through 29. I say 29 because we're not going to do 30. 30 is very similar to a problem from section 2 that we didn't do, the very last one in the notes. Anyway, simplify each expression, write each in simplest radical form. Okay. So we're going to use some exponent rules here. So remember, these can be helpful to convert to exponents if they're not in exponents already sometimes, but they are in exponents, which is nice. And so we're going to utilize that fact for us. And so x to the power of 2/3 times x to the power of 11/3. We have common denominators, which is nice because when the bases are multiplying, we add the exponents. So this is x to the power of 13 over 3, which before we turn this into a radical, let's make this a mixed number, which is 4 and 1/3. Now we can turn this into a radical, x to the power of 4 times the cube root of x to the power of 1, and congrats, we simplified it and turned it into a radical, aka simplest radical form. 23, same thing, but instead of x's, we have 32. So they're both 32. We add the exponents. Common denominators already. So 1/8 plus 3/8 is 4/8. So that's 32 to the power of 4/8. 4/8 reduces very nicely to 1/2. So this is really the square root of 32. Now we're not done here because we can simplify the square root of 32. That's the square root of 16 times the square root of 2. And so this ends up being 4 square root 2. And now we're done. Number 24. These ends are multiplying, which means the exponents add. So 7/3 and 3. We can't add them in their current state because they don't have common denominators. This 3 is technically over 1 in the second exponent, and it needs to be over 3, meaning we're going to multiply the top and the bottom of the fraction by 3, giving us 9/3. Now as we add these, we get n to the power of 16/3. Turning that into a mixed number, 3 goes into 16 5 times with 1 left over, so 5 1/3. Now we can turn that into a radical, n to the power of 5. Sorry, my brain was buffering hard there. N to the power of 5 times the cube root of n to the first, or just n. On to number 25. We have a 7 on the top, 7 on the bottom, so the same base dividing, it means we subtract the exponents. Thankfully, common denominators again, otherwise we'd have to work to get common denominators. So 9 minus 1 gives us 7 to the power of 8/4. That reduces very well to give us 7 to the power of 2, giving us one of our easiest answers today, which is just 49. No need for a radical here. Number 26. You have an exponent to an exponent, a power to a power, so we have to multiply these together. You do top times top and bottom times bottom. We do want to look to see if we can cross-reduce, but there's no cross-reducing 2 and 1, nor is there cross-reducing 3 and 2. So as we multiply straight across, you do k to the power of 3/4. 3/4 does not become a mixed number, nor does it reduce, so we just convert it to a radical. So it's the 4th root of k to the 3rd, and we call it good. If you wanted a more in-depth teaching on problems like 22 through 29, by the way, that would be found in section 2. 27, 1,296 to the power of negative 1/4. Now be careful, this negative did not print well, so take heed. Negative exponents mean they move to the bottom of a fraction. And if it's negative on the bottom of a fraction currently, negative exponent, then it goes to the top, to be clear. So 1,296 to the power of positive 1/4 now. So nothing else changes except for the location and the sign of the exponent. And that would be the same thing as the 4th root of 1,296. Now, fun fact, that's a perfect fourth. How could you know that? Well, you could write out a list of perfect fourths, and it would be your 6th one. Or you could type it in your calculator, the 4th root of 1,296. Hit your math button, go to the x root option, and type in the problem. And it gives you 1/6. On to number 28. More division here, 125 to the power of 1/3 over 125 to the power of 2/3. So we have the same base again, and so we got to subtract these exponents. And so 1 minus 2 gives us negative 1/3. Or you can always say, instead of calling it a negative 1/3, it's just going to move to the bottom anyway, so you could shortcut this blue step out of the way and say, since the bigger number was on the bottom, do big minus small, and leave your exponent and leave your term where there was more exponents, where the bigger exponent was, which was the bottom. Now the exponent of 1/3 means it's a cube root, so 1 over the cube root of 125. So as we look for perfect cubes that go into 125, we may notice, hey, it is actually itself a perfect cube. It's 5 cubed. And so this becomes 1/5. Last problem today, 4th root of 3 cubed over square root of 3. Well, we saw problems like this before in 7.2. So what do? We turn these into exponents. That's how we solve these, because currently we can't just divide 3 and 3. We can't subtract exponents. Why is that? Because these are different indexes. And so we turn these into exponents once again, where on the top of the fraction we have 3 to the power of 3/4, and on the bottom of the fraction we have 3 to the power of 1/2. Remember, it's the exponent over the root or index, so this is like a 1 and a 2 here secretly. Now, in order to subtract now these exponents, they need to be common denominators. So this denominator of 2 in the bottom is going to be 4. So in order to do that, we need to multiply the top and bottom by 2, which gives us 2 over 4, giving us, as we subtract, 3 to the power of 1/4. Converting that back to simplest radical form is the 4th root of 3. And that wraps up section 6.5 of Algebra 2.